Casey. Can you hear me? All right, I'm gonna get started. Yeah, I think that's going to happen with the Wi-Fi. I think the Wi-Fi's been a little funny today. And it's coming through the it's coming through the lapel, so all right, welcome. Today I'm working on a DI box. I have this box here, some parts, some transformers, a loud banging radiator behind me, some inputs, some outputs. These are both vintage units actually that I got out of one tape machine and one old mic preamp. A tube socket for my transformer. A few switches, we'll see how many we can get installed today. But essentially we have a ground switch, a ground lift switch, a attenuator switch to choose between two different levels of attenuation, and a true bypass switch, which I have a feeling we're not going to be able to install this today. We might run out of time for this one, so in that case, I'll just go for the installation of these two. Some rubber feet, miscellaneous screws, nuts, washers, the all-important schematic with a little bit that I cut out here. I'll describe that later. And some knobs. Joanne asks, when does time run out? I'm thinking like an hour 20, hour and a half. I'm not sure any of us has the attention span at the moment for more than 90 minutes of pedal building. You can kind of see I got a head start here because doing this stuff in real time is real time consuming. Feel very out of fun. Some resistors for our attenuation network. You might recognize these three resistors here. I'll come back to this in a second as well. And oh yeah, I wanted to talk about these knobs. Here's the fun thing that you at your home get to do. You get to choose what knob goes on this box. So we're going to call this one number 1 in no particular order, and I'm going to set these out in this order. Number 1. How would that look? Boom, that's number 1. Okay. Number 1 goes here. Number 2, boom. Also pretty good. Too much power with the first one, Casey says. All right, that's number 2. And number 3, classic chicken head knob. That is the name. That's the name for that knob. Boom, 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 boom. But I don't know. That's number 3. So 1, 2, 3, they'll just be sitting up here the whole time. I hope I don't push them out of frame. I might. Additionally, here's my box. You can see I actually got a good head start on this. If I hadn't drilled these, drilling these took quite a while, and this box is pretty serious steel. And if I hadn't drilled this, this would be a 3-part series. So I'm going to start by putting the feet into this box. And fun fact about this box, the holes came drilled for the feet. And these are just some feet that I bought from an online supplier. I go from a few different suppliers, but this is one of them. This is from DigiKey, but there are a number of suppliers, and of course, use the feet that you like best on your box. These are cool because they just press in. And then to get them out, you would kind of have to pull hard, and I think actually that's why they're kind of long. You could pull them in or out, but that's going to give us some sturdy rubber foot action for this. I keep calling this thing a pedal, but it's really more like a desktop box. The difference between a pedal and a desktop box, I guess, is that you put a pedal on the floor. So if you really want this to be a pedal, put it on the floor. So we've got some votes already. Casey says, well, let's see. Let's go back here. Nellie says number 2. Casey says number 1. And Joanna also says number 2. Oh, she likes number 1. Joanna, you have to make a decision, but you don't have to make a decision right now. We've got some time. She likes 1. She likes 2. I'm actually up in the air as well. I'm not going to bias anyone with my votes, but I'm undecided. Okay, I've got a hot soldering iron over here. I've got a few tools. I've got some extra wire and some drivers over here, sockets. I could use either one of these transformers. I think most people are going to opt for a bigger transformer, and since this box is pretty big, I think most people would go for a bigger one, but I happen to know that this one sounds really nice as a base DI, so I'm going to go with the one that I have used and that I know sounds great. Another time, I'll turn one of these into a desktop studio high Z to low Z box, but today we're going to use this one. These are both from 2 different Bogan microphone preamplifiers, probably not 10 years apart. This is like late 50s, early 60s. This is like mid 60s probably. Mid 60s up to possibly the late 60s. So let's talk a little bit about this schematic. So this is the thing that this is the main event right here. This means transformer. And what we want to do is get our input signal, which on a guitar or a bass guitar is a 10 kilocycle, or 10 kilo ohm, not kilocycle, kilo ohm. 10 kilo ohm impedance output. Basically, it'll go through whatever it goes through. It's going to flow to this transformer. This side of this transformer is set up for 10K. This side of this transformer is set up for 600 ohms. So the problem would be without this, if you tried to plug in a 10 kilo ohm output into a 600 ohm input, you'd have a mismatch, and it would give you probably a really fuzzy, distorted tone that is not very pleasant, and probably also very muffled, because 10,000 to 600 is a pretty big variance. So this transformer kind of solves the problem by transforming this high Z signal into a low Z signal. And it happens to be balanced. So we can send that directly to a mic preamplifier and use the mic preamplifier stage of your favorite mic pre or audio interface. Now, truth be told, this problem is also likely solved in your interface. Most interfaces have a high Z instrument input right inside, usually between these 3 pins of a mic preamp input. However, it's a slightly different tone, and if you want a really vintage sound, you're going to go for the really vintage parts. So that's what we've got here. All right, let's get to work again. So to start, I'm going to show you that I mounted this in here. This is what my transformer is going to mount to. I've got this labeled off camera here, but this is the input, the ground. This is also a ground. These two, this is going to be the minus, the cold signal, and this is going to be the hot signal, number 8 there. So I'm going to start soldering and see where that takes us. So we're going to solder the output of this. Like I said, this is going to be the input. This is going to go to our first switch. Welcome, Maya. Maya is also a tech. Maya, do you have a YouTube channel? I've seen some of Maya's work on Instagram, and Maya's... Hey, how you doing, Maya? Maya's also an incredible musician, as are, I think, everyone who's currently on this chat. All right. So, here's what we've got here. I'm going to try not to explain too much, but I do want to hit some basics so everybody knows what's going on. We've got the hot, cold, and the shield and ground. So what's going to happen here is I'm going to go shield here, essentially to the switch. And that's going to, the switch is going to break the circuit for the shield, and that'll give us a ground lift for the output. The other side of this is going to go straight to ground, and that's going to go on this wire right here. So this is going to go on one side of this leg, and that's going to go on the other. This is going to go in here. So that said, these are going to go on our tube output, or excuse me, our these are going to go on our transformer output pins. So this must go in here. I'm not going to bolt it in yet. It's a snug fit, so I'll come back to that. Let's see. No. This has to go in here first. So I'll come back to that right now. I'm going to tin this with a little bit of solder. Can everyone still hear the music, or is it just for my benefit? Casey wants to say, Casey says, why is the ground lift important, Frank? Ground lift is important because if you get a buzz that is related to a ground loop, you're going to want to be able to break that loop without doing much work. You could clip a wire on one end of your cable if you needed to, but the easiest solution is to have a ground lift somewhere. So you'll find most pro studio gear has a ground lift. All right, solder joint number 1. I need one of those little counters in the bottom of the screen. Okay. So with a tinned joint and with a pre-tinned socket, it won't need much. Just a little to freshen it up. I would consider doing a solder lesson if people were interested. But if you already think this is a little boring, you will absolutely hate a solder lesson. And did I check it out? Nope. So it's going to have to go this way. Did I save myself work or make myself work? Maya says, excellent tunes, and hi to Nelly. Thanks, Maya. These tunes are sort of up for debate sometimes. I get comments on the channel that are like, loved everything but the song. So I know that music is a super subjective thing. Okay, also basically pre-tinned, so I just need to reheat the joint. So the other side of this is going to go to here. We'll get to that in a second. But you can already see that that would break the circuit between the ground here and the ground here. So okay, I'll mount this quick, and I think that way is up. I'll just come back to that. Okay, let's work on this switch. The switch is a two-way switch. So in this case, we're going to use the center bit for our input, and then it's going to flow through either side of this depending on which way this is turned. So what I'm going to do is attach two of my attenuators on either side, and the input will flow through the middle, out through the other side, eventually through a shunt resistor, and then to ground. So this is going to look like that and that. So I'm going to go like this. Oh, yeah, Casey offered last time to set up or excuse me, to send music for a video, and I'm going to hold you to that, Casey. So when I'm soldering, I like to get a good mechanical joint first before I solder, and that will always yield a better result in the end, whether it is through longevity of the part or the joint, or just good solid electrical connection. So give it a good clamp, without, you don't want to break your contact point, but okay. Are we already past solder joint number 3? So I also try to go above and below, or on the front side and the back side of a joint, to make sure that you get a good, clean, shiny joint. It's harder than it seems sometimes. Oh, Maya says that's a champion clamp. Yeah, this is a pair of surgical hemostats that I got about 25 years ago, and I've been using them ever since. All right. Okay, working on this next joint. I hold the tip down, add solder to both parts, flow to the front, flow to the back, up and away, and I try not to move the part too much. The more still you can keep the part, the stronger the joint will be. Nice shiny joints. These are probably strong enough to rip off the contacts, so I'm going to try to be careful from this point on. Set this down for a moment. Let's work on our input here. I think, for the sake of time, like I said, I'm going to omit this switch because it's a convoluted concept. You've got 2 poles and 2 throws. One side would be true bypass, so you have an in and you have an out on this side, and on the other side you have an in and an out. So it flows in through here, then goes back out to the transformer. So I'm not going to use this today. We'll just have one side padded a tiny bit more than the other, and it won't be a big deal. But in the final video that I post for this, I'll have this installed, and I'll show you the full install of it, because, like I said, I think even though we're going to be hitting close on this time. Okay, so no switch. We're going to come to here, and this is our 2-way switch. And you probably already recognize that. 2 resistors, 1 shunt resistor to ground, flows out. Okay. All right. Joanna says, I stole these from Nellie this morning. Nellie does have some pretty sweet pliers, but yeah, these little clamps my sister gave to me, and I've used them ever since. I think I told her that a few years ago, but I don't know if she would remember that. I'm sure she remembers giving them to me though. Okay. Water time. All right. How many people are watching on their phones currently? let's work on the input. Casey and Joanna are watching on the computer. Maya's on the phone. I don't know why that struck me. I'm just curious. I'm always interested to know how people are watching things these days. Okay, let's go back to our little schematic here. On my off camera, I'll put it on camera here. We've got number 9 is the input. So input is here. This is a switch when we don't need a switched input for this. So really what's going to happen is, this is it would come in here like this. And it'll break, let's get this closer. It would come in here and it breaks that grounding circuit. So that's how a switched input works. This doesn't need to be switched, but I just happen to have it and I like the look of it a lot. So with that in mind, this is the input. It goes to here. We need to use this guy. This is probably a little bit too much wire, but I'm not going to sweat it. I sometimes don't tin a wire that I'm going to put through a hole because it's easier to wrap a copper wire that isn't tinned. So in this case, it's not tinned, and I'm going to wrap it all the way around as much as I can to get that good mechanical connection. I've seen joints in some gear that was really well wrapped and unsoldered. It's rare, but you see it when if you work on enough gear, you'll see it. Okay, touching both parts, adding a little solder, touching up from the back side, pulling away. Pretty close. It's a little dry. I'm going to add a little more solder. I'm going to go from the back side this time, actually. Yeah, that's better. You don't want globs of solder. You want to still be able to define the wire. And in this case, we can still see the wire. Okay. That's our input. This is where our output's going to go. Now we need to which one to cut. I need to cut one side off simply to put our switch in. Cut it right in the middle. A quick, easy way to strip wires. If you don't have a great pair of wire cutters. Okay, so remember, this is our switch. It's going to get the input. This is going to come up through like that. Is it going to fit? Yes, it will. With most things, you don't want to solder for more than about 5 seconds at a time. Okay, looks good. That's how it's going to look on the inside. And now, we need a ground from here. And that ground is going to go straight to this main ground. And it's not going to ever get lifted. So this is our main ground. If you look inside, it's also important to grind away some of the paint. It's hard to see. I basically did this on the inside for this ground. And that helps conduct all of the steel parts together and creates what we call ground. Let me just wrap my head around this particular ground. Okay. I don't have any more green wire, but I've got some brown wire. Probably not the safest looking method for wire stripping, but if you've got thin wire, it's an easy way to strip. Okay, ground here. This is one of those tricky ones that's going to need a little more. Get that all the way around. Okay, that'll stay in place. More wire will also use a little more solder, but I can live with it. So the front side and the back side. All right. Can you all hear this song? I put this in, I don't remember what video I made this for, but we have a keyboard that does a really great auto bass, and this sounded so much like a How It's Made video that I had to make something like that, so I threw that in here as well. Okay. I'm going to do the inputs and outputs on this. So we've got hot, cold, shield. Right? It really, Maya says it really does sound like how it's made. I almost wonder if they had a similar keyboard, the person who made a song that sounded like this. Okay, so according to this, my little off-camera, on-camera pinout, we've got cold, and we've got hot. So cold is pin 1, 2, 3, 4, 5, and hot is pin 8. So why don't we do? No, we won't do that. We'll do this. Hot output pin 8. Okay, so I'm going to give that a quick solder so I don't move it around too much. And I've been trying this, I bought a pound of this really thin solder. I'm still not sure if I like the thin versus the thicker. I seem to run out of solder before I'm done with a joint if you're not really well prepared. Touch it up. Okay. That's hot. 5 cold. 2, 3, 4. 1, 2. Oh, these are bridged. 1, 2, 3, 4, 5. So I'm going to go from the inside. Maya, what's the last thing you teched? That's ready. So I want to keep this as neat and straight away from the other pins as possible. So this is something I do sometimes. I sometimes clip my hemostats nearby to make sure it stays straight. Also acts as a heat sink if you need it. Guitar maintenance. Maya was doing guitar maintenance. That's cool. So you've seen plenty of this little pin work. Guitar switches are my least favorite type of soldering work. It's a myriad of complexity sometimes. Okay, let's strip this. Casey's working on a project. You want to spill the beans on your process? Yeah, right. Maya says, amen. Casey, want to spill the beans on your quarantine project? This is like the most hack way to do that, but it happens to be very quick, and this is very thin insulation. I will probably edit that out of the final version. I'm not working that hard on it, but yes, I'm getting parts to make a switchable transformer box for mastering. Excellent. So this won't be very far from that. And truth be told, Casey and I have been messaging about transformers and stuff all week. So this needs to go to ground. It's going to wrap around here. Whichever one has the least amount of stuff going to it. Now the fun part of all of this is going to be mounting this in the box with everything hooked together. And I'm going to heat sink my my resistor here. I don't want it to burn up. I'm going to do it in a way that also doesn't fall over too much, but I don't want to be able to do that. I'll have to set this somewhere in here. It's nice to have two pair of clamping pliers. I didn't pull my other pair of clamping pliers out. Maybe I will in a minute. And I'll leave this on here for a second to absorb some of that heat so it doesn't fry this resistor. Even feeling this, I can tell it's not super, the resistor didn't get super hot. Casey says, Frank, you need a helping hand. You're referring to those little elbowed, armed, clampy things. And I used one recently to help a friend with some XLR cables, and it was as cumbersome as anything else I've used. So if you're good at that, if you're good at using one of those, go for it. But I was not impressed with how much flexibility it gave me, which was not as much as I wanted. All right, if you're just arriving, welcome. We're about halfway through with this transformer desktop pedal. I'm going to call it a pedal. And here's what we've got done. We've got our input basically wired. We've got the input going to this switch. We've got the switch going to either side of this attenuation circuit, which is really just an L pad. We've got one resistor here, or excuse me, one value here, one value here. That's the either or. They'll always flow through this one, which is here, to ground. Thank you. And to ground here. And then they'll come out, the signal will come out through this joint here. And that's going to go to the hot leg of our transformer. So, the hot input of our transformer, which is here. And if you want to weigh in, you can. It's up to you to decide which of these three knobs are going to get used. I'll do another quick. Oh, I don't want to spoil the ending here, but this will give you a better idea. Knob number 1. Knob number 2. or knob number 3. So in that order, make your decision, and I'll put the one on that everyone decides. Democracy in action. That's what I'm about here. Okay. I think we're ready to install this. Casey still is sticking with number 1. Nellie is still with number 2. I believe, Nellie, you were with number 2 a little while ago. Maya also says number 1. Uh-oh, number 1's heating up. Maya says, or 2. Yeah, number 1 and number 2, I think they seem to be the favorites so far. Number 3 is known as chicken head knob, as I mentioned before. I don't know if that is funny these days or not. Oh, have I ever had anyone paint my boxes? I haven't really sold any of these. And I'm certainly not the inventor of this box. I meant to mention, though, I made these for myself, and the person who made this, Casey, I might have to ask you to look up the name of the person that made this. I sent Casey a link to an article about these boxes, which were kind of designed in Motown, in Detroit, and used on a lot of Motown records. James Jamerson had one of these boxes supposedly, and they came back into fashion. If they ever went out of fashion, they came back into fashion. And I made one for myself a long time ago. I got a. I'll stop fumbling with this for a second here. Ed Wolfram, Casey, thank you. Ed Wolfram started making these boxes when he was 16 years old, according to his own manifesto. And he got involved with a company that started making them, and then they all fell out of business together. So he's no longer associated with making them. He said that they're incredibly expensive and time-consuming to manufacture, and I can attest to both of those things. What if the rest of this video is just me trying to get this nut, or this bolt, this half nut, half bolt inserted into this? I'll show you a box that I made a long time ago. Jenna says, "You're nuts," and I believe she is right. So, the short answer, Maya, no. No one has painted one of these boxes for me. There it is. All right. Found this just for this occasion. Give it a quick little spin. A phone call that I'll get to later. That was my mom. I didn't take it. Maya says, how often do you go live? This is my second one. I did this the other night, and it was a huge success. So I thought I would do it again, and I can already say huge success. There are ones of people watching, and I really appreciate that. Welcome, and thank you. I guess open hands to me are a sign of thanks. Okay. Back on track. This gets mounted. This is going to go to our output, and our ground goes to here. Okay. Let me wrap my head around all this. Let me turn some music back on. Anyone who missed the first half of this video, you get to hear the music from the first half right now. That's what's happening right now. Okay, we're wired here. We've got input, we've got ground, we've got the shunt resistor, we've got input to input, we've got a switchable switch. I guess we are going to hook this ground up to our switch like I promised we would do. Did I make it too big? I think I made it a little too big. You don't need a huge ground cable like this. I just happen to have a pigtailed ground cable. I'm going to open up this solder joint. It's a little closed. And that may have made it worse. This is thick cable, so it does kind of demand a little extra solder. This is another one of those songs that kind of reminds me of how it's made too. Welcome, LJ. One advantage to doing it live is you don't have to edit it. That is great. I am actually enjoying that. Okay, we've got our ground switch working. So remember that's going down to the ground from the output of the connector. So that's where our switch is, coming up from here, switched on or off to here, which is the main ground. So now that these are basically wired up, remember this is going to be our input, this is going to go to our switched resistors. Let's get this in a position where it won't cause much trouble. And this is probably going to be the most finicky part of the entire process, mounting this all together. That's nice and tight. I know that it needs to sit in here. I'm going to carefully bend these out of the way for now without breaking my contacts. Just for a second. You get about 3 bends on a resistor lead. 2 to 3. The better ones give you 3. 1, 2, 3, and then it's toast. Okay, actually this is a better one. We're getting maybe 5 or 6, but it's really, that's called work hardening. It'll break right off. Oh, this is pretty good. I know there's a rating for that on parts, specifically parts like this, how many times you can bend it back and forth, and it will add up quick. It will surprise you if you do this long enough. Okay, getting this in here. This ground is going to attach. We'll get it in here somewhere. So, as I recall, I had this sitting like this. Just sneak this under. Okay, gives us a little more room. And this is going to point toward the back. So, need a screw. Ooh, this is going to be trouble. I can just see it. I might, in fact, I'm going to have to, I can tell. Yeah, Casey says that resistor is embarrassing you. Yeah, right. It took like 100. I said, oh, you only get 3 chances. It took like 100 bends. If only everyone were that way. If every resistor were that resilient. Okay, this is gonna sit like that. Yeah, this is it. About 30 minutes left. Anybody want to take bets on whether or not we can wire this thing up in about 30 minutes? Nellie says, and what I'm guessing is a Rob Schneider voice. You can do it. I don't know if she meant that or not. but that's the way I said it. Okay. This is, I know one of these is going to be tricky to get in, but if it won't fit under here, I'll just put it on another screw, maybe under the lid, if that's the easier thing. I did it twice today though, so I feel pretty good about it. Going backwards, sometimes it's easier to spin your screw or bolt backward to find the thread. Okay, twist this into position, and actually I think that's going to be, maybe that'll be the best position right here. I had it in the corner earlier. Yeah, we'll leave it right here. See how that goes. Okay, nice and tight. Again, if you're just joining us, make your vote. Which knob? 1, 2, 3. All right. Casey thinks we can get this done. Nellie thinks we can get this done. I think we can get it done. All right, let's tighten this up because, oh, that signs a music change. I think that's an outro. There we go. Now, if you noticed, I made a little hook on the end of these resistors. And that is where this guy's going to go. And this gal. So, you know what? I'm going to grab my other pliers. I know you thought I only had one pair of hemostats, but I actually have 2. Look at this. I'm rich with hemostats. I don't use them for what you think I probably use them for. Okay. So I'm going to carefully twist this up into position. Okay. And you can see made the contact in there, and that's where this is going to go as well. This is like terminal strip construction or eyelet construction, which is much easier than point to point, which is what we're doing. This style of components ending at one point, starting at one point, ending at another point, is called point to point construction. And okay, I've got this in here. I'm going to clamp it to get a tight connection. Not too tight, because I also don't want to run out of space here. Okay. double check our schematic so that we know we're in the clear here. Input to one side of the L pad attenuator, there to there. L pad to one side of the shunt resistor, here. And the output of this at the same juncture here, which will go to one leg of the transformer. We're ready to solder. Let me just double. Yeah, looks good. Sometimes if I'm creating a joint like that, like I call it a flying joint, I'll put a piece of brass tubing. And you can create really strong joints with a little piece of brass or copper tubing. So you can get two flying joints. I do that sometimes on mixing resistors like this, where they end up in one spot. And especially helpful if you have a terminal strip like this. Or a myriad of reasons. Okay, we've got a ground here, and these are both going to go to the same place. And I think that's our last connection. I'm glad we didn't add the other switch. It would have been too much, I fear. So again, I'm just going to make a flying connection here. And I'll tape that up. And that's our last one. Okay. I'll just use a little bit of tape here. I've been enjoying the new Livestream, the sort of new Livestream culture that we're in, and it inspired me to do this because it's something I've been meaning to do for a long time. Sometimes it's nice to see that other people are doing it. Okay, that's the inside of our box. Everything's accounted for. It's time to test it. I'll put some nuts in here. Well, this is going to be, I might only do one. This is going to be dreadful. Maya says, I'm glad you're sharing knowledge, and thank you, Maya, I appreciate that. I've been a teacher on and off for many years of my life, so I like to think it comes sort of naturally. And Nellie says, the knob. What about the knob? And we'll get there. quite there yet. Nope, not that one. That was the wrong one anyway. That one didn't want to go on. This is the one. Casey says, that nut is making you nuts. He's right. It was just the wrong one. The right size. Not the right one. All right. We'll do one. I'll do the other ones later. We've got two other things to do. I'm going to put the switch inside just for the sake of saying it's in there. So this is where our true bypass switch will end up. Someday, the day that it gets installed. Okay, this one needs a little tighten, I believe. And as does our input. Okay. Ground these out so that we have a nice... Ooh, is it bad luck to put this lid on? It's like assuming that it's going to work. All right, what's the verdict? Did we come to a final verdict on the knobs? Because it's time to install one. I'll even clear up our space for the official knob install while everyone fights about or debates, I should say, debates about which knob ends up on top. We got knob number 1. We got knob number 2. And we got knob number 3. Seems like knob number 1 gets it. Let me look. Let me just do a quick check. Casey likes 1, Joanna likes 3, Nellie likes 2. Maya might be the tiebreaker. I'm gonna grab my base. I'll be back in. I'm back. Okay. Wow, 3. Maya says she came around to number 3. That's a little crazy. No one has even mentioned 3 yet. Did anyone else go for 3? LJ voted. Oh yeah, that's right. LJ voted. Oh, LJ voted for number 1. All right. I think that's it. Thanks everybody for playing. But it looks like number 1 wins. All right. This is gonna be satisfying. Oh, wrong position. Not as satisfying as I thought. We just get a little do-over. Which side is which? Left. Okay. I've been waiting to put this knob on something for a few days. All right, there we go. This is it. Okay, feels good. Feels like 1950. Okay, bass in. Nelly says, where's the knob emoji? And I don't know. Okay, so bass in. Bass out. Click. All right, let's turn this music off. Check our inputs. And we'll get the moment of truth. Get everything turned up. Oh, we have sound. Is it going to get louder or quieter? Louder. Oh, quieter. Okay. So that's the more attenuated side to the right, our less attenuated side to the left. Cool. We did it. All right. Well, I guess this is the moment where I thank everybody for stopping in and promise that I'll connect that guy back at some point. Any questions before I leave you all to the rest of your evenings? I'm just going to keep doing this for a while. Yeah, that's a pretty satisfying knob. I'm excited for this one because it's a 2-position knob. I'm pretty excited for that one too. All right, folks. Thanks so much for joining me. I'll, oh, before I go, I promised to show you a different DI box I had made. This is actually a transformer DI that I used for a long time. And I turned it back into a microphone preamp the way it had been originally designed. That said, thanks everybody. Maya, Casey, Joanna, everybody who dropped in. Appreciate it. Talk to you all soon. See ya. Is my sound still off? Bye.